So I want to cover two things in this video, and the first one is an Argand diagram, what they are, they're very simple, and how you plot points on an Argand diagram. The second thing I want to cover then is the modulus of a complex numbers, what that is, how do you calculate it, and how that ties in, I suppose, with the Argand diagram as well. So I have three complex numbers here that I'm going to use as my examples. I'll label them 1, 2, and 3. And what I have on the left-hand side here looks very like coordinate geometry plane. So what you would plot XY points, so 3, 2 on the coordinate plane. And really, an Argand diagram is just a fancy name for coordinate geometry with complex numbers. So when we are dealing with normal coordinate geometry, if you are plotting a point, what are you going to have? You're going to have, let's say, the point 2, 3. Well, we all know that point 2 is the x coordinate and the point 3 is the y coordinate. And then you come along to your coordinate plane, and we know the y is up here and x goes along here. You find 2 on the x. So let's say that's 1, that's 2, and then you follow that line up until you get to 3 on the y. So let's say the numbers go like this, 1, 2, 3, and so on. And over to x, so what was that? Across the hall and up the stairs. X comes first, so that's across the hall, and then y comes second, and that's up the stairs. And that is your point up here. An Argand diagram is almost identical to that. And instead of having x and y, what you have is you have a real part and you have an imaginary part. So this axis up here is your imaginary axis. It's basically counting up i's. So where I have the number 1, 2, 3, and 4, and then -1, -2, -3, -4, what they represent or what they stand for is 1i, 2i, 3i, 4i, -1i, and so on. The real numbers, so this part that doesn't have an i on it, they are on the what we would call the x-axis, but we call it the real axis in an Argand diagram. So really, your y-axis becomes an imaginary axis and your x-axis becomes a real axis. And you plot them exactly as you would have done in first year. So if we take point 1 here, 3 plus 2i, again, we go to 1, 2, 3 on the real axis because it's the number 3. And then you go up to 2 on the imaginary axis, and that's your point. So this is point 1, 3 plus 2i. The second point, you sometimes see this here, that you get the imaginary part first and the real part second. So just watch out for that. Again, I just out of habit tend to do the real part first. So you go to -4 on the real axis, and then you go to +3 on the imaginary axis. So we go up to 1, to 2, and to 3. And that's our point here, 3i -4. We could easily write that as -4 plus 3i also. It's exactly the same thing. And the last example that I'll use here is 2 minus i. So again, over to 2 on the real axis and down to -1, okay, on the imaginary axis. So we're talking about how many i's, and when you have just -i, you're talking about -1i. So this here is the point 2 minus i. If we go down, this is a diagram out of the book on what page, I'm not sure, 195 in your textbook, and it gives you lots of different points here, and they're plotted on this Argand diagram. Now you can see that they've done their Argand diagram slightly differently here. They have 3i, 2i, 1i, and then -1i, -2i, -3i. It really doesn't make a difference which one that you use. The labeling is the most important part up here. As long as you put the imaginary, so IM for imaginary, and we use always the letter Z. So where we use X in coordinate geometry, there's always the letter Z for complex numbers. So that basically is maths for imaginary part of Z. This is real part of Z. So if we go down here, we can see the number 2 plus 3i. So again, over to 2 on the real part, the real axis, and then up to plus 3i on the imaginary axis, and you put your dot there. 3 plus I, 1, 2, 3 on the real, and 1 on the imaginary axis, because it's 1i. 4 plus 0i. So again, that's just the number 4, and that appears on the axis here. So all real numbers with no imaginary parts are just going to sit on that line. 5 minus 2i, real part is plus 5, and the imaginary part is minus 2. So you go down over to 5 and down to minus 2. 0 minus 3i, that literally has no real part, so you're not going left or right here, you're just going straight down to minus 3i. Minus 3 minus 2i, so again the real part to minus 3 and the imaginary part down to minus 2. So you get the idea of how to plot a point on the Argand diagram. So let's look at a sample question from that. This is question 3 from page 195 in your books. So they're asking you, and I'll do the solutions just over here, they're giving you the two complex numbers that you have to deal with here. So Z1 and Z2. Now this is a very common way of giving a question. You have to show where each of these solutions or where each of these answers are on the Argand diagram. So the first thing that I'm going to do here is I'm going to put numbers into my Argand diagram. Okay, so I will put in point 1, 2, 3, 4, and these are your minus ones. And then now you'll notice I am not using I, but what I'll do is I'll put, label that as the real and label this as the imaginary part. Okay, so what is 1? The answer is 1. You don't have to do any calculations, it's just Z1. So they want you to plot 2 minus I. So you go to 2 on the real part, you go to minus 1 on the imaginary axis, and that is the solution there to 1. So I'll put a little 1 beside that. Part 2, you have to add the two complex numbers together. So your two complex numbers are 2 minus I, and you're adding on 1 plus 3i. So when you're adding complex numbers, you don't need to put brackets in. You are bringing the real parts together. So 2 and plus 1, that gives you 3. And then minus 1, which is minus I, and plus 3, that gives you plus 2i. Okay, so 3 i's, take away 1 I, gives you plus 2i. So now if we want to plot that, we are going to go to 3 on the real part, 1, 2, 3, and go up to plus 2 on the imaginary part, and that is the solution. Now I would, instead of writing in that, if this was an actual exam, I'd write in the complex number there. I'd go 3 plus 2i. Okay, so we might just do that for the first one as well. That is 2 minus I. Third part, you're asked to calculate Z1 and Z2. So that is 2 minus I multiplied by 1 plus 3i. One of the most common mistakes that I see is mistakes bringing the number from here down to here. So double check once you have that written that it is exactly as it is on the paper, and then go ahead and do your multiplication. So 2 multiplied by 1, so what do we get here? We get 2 plus 6i minus 3i squared. So we know that I squared can be replaced with minus 1. It is minus 1. Minus 1 by minus 3 gives you plus 3. 2 minuses give you a plus. Plus 3 and 2 gives you 5. Okay, so let me run over that again. I squared is minus 1, so you have minus 1 multiplied by minus 3, which is plus 3, and 3 and 2 is 5. Add your imaginary parts together, and you're going to get plus 5i there in that. So that's the solution for part 3. You plot that then onto your diagram. 5 plus 5i, 1, 2, 3, 4, 5, plus 5i, 1, 2, 3, 4, 5, and that's 5 plus 5i. And the last one is I times z2, okay? So I multiplied by z2, and what is z2 from up here? It is 1 plus 3i, okay? So when you multiply those two together, you are getting 1 times I is I, and 1 times 3i is plus 3i squared. Now we know I squared is minus 1, so that becomes I minus 3. And again, you do tend to have the positive, whatever term is positive, whatever part is positive would tend to go first. So you tend to write that as I minus 3 as opposed to minus 3 plus I. But again, they are exactly the same. You're not going to lose marks there by writing it like that. It's more of a, what I call a maths grammar thing. So minus 3 plus I, so we go back here, minus 1, minus 2, minus 3 is the real part, and plus I, you go up to 1. So that's going to be nice and awkward in there, and that's minus 3 plus I. Okay, so that's your Argand diagram. That's how you plot numbers and how it generally will come up in exams. So the second and final thing that I want to talk about is the modulus of a complex number and what that is and how you would work that out. The modulus of a complex number. So let's say that we have z1 and we'll use the numbers from before. We have 3 plus 2i. The modulus is written like this. So it has two parallel lines, so a line either side of it. And if I plot 3 plus 2i, so I go 1, 2, 3, and plus 2i, I'm going to end up here. What the modulus is it's the distance from this point back to the origin, back to where those two lines cross. So the length of that line, that is the modulus of z. Okay, so it's that length that we're talking about there. Now, how do you find that? You find that by using Pythagoras' theorem, because we know this distance here, we know that distance there is 2 units, and we know this distance along here, sorry, I'll be a bit more accurate with that. That distance over there is 3 units. Okay, so according to Pythagoras' theorem, because that makes a nice right angle triangle there. According to Pythagoras' theorem, what's the hypotenuse length here? It's 2 squared plus 3 squared, and it's the square root of that. Now, in your books, it gives you the formula. In your log tables, it's going to give you the formula. The formula is a squared plus b squared, and it's the square root of all of that. So when z is equal to a plus bi. Now, what's a and what's b here? It's 3 and 2. What you are doing very simply to find the modulus is you take the real part and you square it. And then you add on the imaginary part, which is 2. So that number that's there, squared. Add those two together and get the square root of your answer. That's all you have to do. So 3 squared is 9, 2 squared is 4, 9 and 4 is 13. So the modulus is the square root of 13. Now we'll leave it at that, because that turns out to be, that's a surd, which means that it's going to come out as a decimal, a recurring decimal. So that's the best way to leave that.